Hi guys and welcome to Learn Extra Live. It is Tuesday, that means that it is physical science with Tracy. Grade 10s, I hope that you are all tuning in. Hi Trace, how are you?
Good and you? Well, actually, I really hope the grade 10s are tuning in because I told my learners today I'm going to smack them tomorrow if they're not. And they need to tune in because today we're going to do revision.
It's an important one.
Yeah, it is. We're going to do physics revision, so we're going to look at wave, sound, and light, electricity, magnetism. I've got some questions prepared, but obviously we need to have questions from the learners to see how they're doing.
I must say, the mindset is love challenge questions. So I think the more questions, the better.
Better it is, absolutely.
Yeah. So Trace, why don't you go take your little spot by the board and I'll give the learners a little bit of a chat.
Okay.
Guys, as you know, just like we keep saying, today's show is sponsored by Liberty. You guys rock. Thank you so much for making this possible. And don't forget to chat to us on the Facebook page. It's www.facebook.com/learnextra, and that's with an XTRA. You can also chat to us on Twitter @LearnExtra. Guys, post all of your questions. Please let us know if you're struggling with anything that Tracy's chatting about. And don't forget that we are answering your questions in the last 15 minutes of the show. So get them in. We also have a Casio calculator to give away, which is pretty cool. We give away one in each show for the grade 10s, 11s, and 12s. So that leaves lots of space and lots of opportunities. All you need to do is chat on the Facebook page, chat to us on Twitter, help the learners out, help each other out, post inspirational posts, exam tips, anything. Anything could get you this awesome calculator. And without further ado, I don't want to take too much time from your lesson. Let's go straight to Tracy. Tracy, take it away.
Thanks, Indy.
Such a pleasure.
That's always fun. Okay, well, guys, we are looking specifically at wave, sound, and light and electricity and magnetism today. What I decided to do, rather than give you an entire information overload, because I could spend the whole hour just talking, and we know that, is we need to look at questions, because that's really where it comes down to. Now, some of you may or may not have started studying for your exams. It depends on when your school's written. Some of you, unfortunately, might have written already. I know some schools have. And if you're like my school, well, you're only writing in a couple of weeks' time for my particular exam. But that's okay. It's still worth being here, being active, looking at what we're doing. And what we're going to do is I've tried to cover as much as I can. Obviously, grade 10s, there's only so much we can cover in an hour. But like we've said earlier, I'd really like your questions off Facebook, because that really makes it a lot easier for us to make sure we're covering the stuff you don't understand. So starting with wave, sound, and light, we're going to cover waves. That's where we're going to start. And what we have is a diagram. You have to excuse my wave. I know it has little jumpy parts at the moment, but that's because I'm not a graphic artist for a reason. Okay, so we're looking at wave, sound, light. We're going to look at a very typical type of question, where here we have a graph. And the problem says to us, study the graph in the diagram. So what we have here is, before I look at any of the questions, we're going to look at what the diagram has, what information it's given to me, okay? So it's telling me that displacement is on the y-axis, so I can definitely calculate things like amplitude, that sort of thing, okay? And time is on the x-axis, so that's quite important, and they very nicely have indicated certain times for us. And if we look at this and we go, okay, well, let's try and see if we can see some stuff on this. If I start here, from here to here, that's one wave. There's a second wave, that's a third wave, that's a fourth wave, and that's a fifth wave. Because remember, it's got to be between 2 points in phase, and it goes down and up. So my diagram has 5 waves. Now, that might or might not be important. A little later on, we will have to have a look, okay? And it takes 4 seconds for these 5 waves to happen, okay? Now, because it's time along my y-axis, it tells me nothing about the wavelength or anything like that, so I can't actually judge how long this is at this point, so we're going to have to leave that for now. Now, first thing it says, use the graph, okay? Very important word here. It says use the graph to find the period of the wave. Guys, this instruction is very, very important, all right? I'm going to give you some exam tips as we go along. Be very careful, because you tend to go, oh, okay, it's this, and you find these numbers out of nowhere. Please be careful. You have to use the graph, which means I need information from the graph. Now, here's also where we got to remember what period means. Period is the time taken for one wave. Okay? Time taken for one wave. So if I'm going to calculate period, which is capital T, not lowercase p, I'm going to need to take the time I've got. So I'm taking the whole time and dividing it by the number of waves, which is actually why I counted them earlier. So we counted that there were 5 waves, and it took 4 seconds. So that means we've got 4 seconds for 5 waves. It's 0.8 seconds. That's the period. So now we go back and we say, well, period is the time taken for one wave. Look here. I've said it's 0.8 seconds. So one wave goes down and comes up and ends before the 1 second mark. I'm definitely correct. Okay? If I got a period bigger than 1 second, then there's something wrong with this graph, because this here is definitely not at 1 second. It's just before it. It's not a completely accurate graph, so be careful about trying to read it off the graph. Okay? Now, next one says use the graph, and this is the big thing for you, because now I want the frequency. And remember, frequency is the number of waves per second. Okay? Now, here, please do not do this. Do not be tempted to go, well, frequency is 1 over period, so I can just use this value. Because you'll get naught for it, because you're not obeying the instruction, grade 10s. This is a very important tool that you've got to put in your toolbox for exam skills, okay? I see this all the time with the grade 12s, is we say to them, use the graph, they do another method, get the right answer, and then they get naught for it because they haven't followed the instructions. So please be careful here. Now, frequency is the number of waves per second. So I'm going to go the other way around here. So I'm going to go number of waves in the graph divided by the time taken. So here, I now have to go 5 divided by 4, and we get 1,25 hertz. Okay? Now I want to show you something. And this is why you got to be careful. If I said frequency, and I want to prove to you that actually it doesn't matter, that the method is important here, okay? Because I also want to prove to you why you get upset with me when we do it this way. You've just worked out that your period is 0.8, okay? So we have the calculator this week, by the way, grade 10s. We found the calculator, though apparently Phil in the grade 12 show knew how to use it. But it's okay. I'll get over it. So 1 divided by 0.8, and that's 4 over 5, 1,25. Okay, it's exactly the same value. Now, grade 10s, they both give us the same answer. But this is what I was saying to you. This, what I've written in white, gets you no marks, though, because you didn't use the graph. Okay, please be careful. If the question had simply said, calculate the frequency of the wave, either of those would be acceptable. Doesn't matter. Why do we do this? Because we're actually testing a concept, not just whether you can actually do an equation. Okay, so be careful here, grade 10s. I know it seems quite mean, but it's not really, because remember, we want to make sure you understand what you've been taught. We want to make sure you understand these concepts of frequency and period and that sort of thing. Next question. What is the amplitude of the wave? Now, this one's actually quite nice, because if we go back to the wave, we go, hang on, wait, hello. Amplitude is, now we've got to remember the definition. It's the distance from the rest position to the maximum height or maximum displacements, either on top or the bottom of the wave. Okay, so we look at this and we go, well, it goes 40 centimeters up, it goes 40 centimeters down. The minus 40 just tells you it's in the opposite direction. So that's actually quite nice. So when it comes to amplitude, no calculation needed. And we will say that the amplitude, there's no symbol for amplitude, by the way, is 40 centimeters. You're welcome to leave it like that. You don't need to change it into meters. It's not an issue. Now, I made a little bit of a oops when I put this question together. So we're going to leave question 4 for now because we actually need to answer question 5 first. Okay. There's absolutely no way we can answer the question 4 before we answer the question 5, but don't tell anyone. So now they say to us, calculate the speed. Oh, no, let's do this. Calculate the speed, so that's v, of the wavefront if the wave moves 0.8 meters, so that's 0.8 meters in 1.6 seconds. Now, grade 10, some of you might have been taught to use a d instead of delta x. It's not strictly speaking incorrect, but that's going to get dropped once you get to grade 11 and 12. So we're using delta x because we're actually working with a velocity. It needs to have a direction. Okay, so speed is change in distance divided by change in time. So we go 0.8 divided by 1.6, and we get, where did I get? I definitely got the wrong answer on my sheet, so let's do this. 0.8 divided by 1.6, and that's half 0.5 meters per second. Okay? 0.5 meters per second. It's fairly slow. Okay? I can definitely walk faster than that, but it's not it doesn't look like it's a very fast wave anyway with a frequency of 1.25. It's not very high. Now, why did I need that? Because in the next question, they ask you to calculate the wavelength of the wave. Guys, without the speed, this graph does not give me enough information because there's no distances on the y-axis. So I can't relate the wavelength to the scale on the time axis because it's not, time and distance aren't the same thing. Be careful, all right? But I do know frequency, which is great, and I do know the speed. So if I go here for calculating the wavelength, all right, I know that let's actually, okay, so we know the speed is 0.5, okay, and we know that the frequency, and we worked that out earlier, is 1.25 hertz, and we want, not having a good writing day. Wavelength.
Testing your skills.
Testing my skills. There we go. So we now need to remember the wave equation, which says to us that V equals F times lambda, where V is 0.5. My frequency is 1.25. We want lambda. Now, to get lambda on its own, which is our wavelength, we're going to divide by 1.25 on both sides. Okay. And I don't have the right answer in my book again. So let's divide. Okay, which gives me 0.4. Oh, come now. Really doesn't like me today. 0.4 meters. Okay, it's a small wave, but we expected that. Okay, so we've actually covered a lot of stuff in this question because it really has dealt with whether you understand the concepts of frequency, period, amplitude, wavelength, and speed. Okay, being able to interpret a graph is a very, very, very important skill. So let's go on to another question, also to do with waves. This is to do with sound. Okay, and what we have here is, I just put a picture of a trumpet so that in case somebody didn't know what it looked like. There we go, yeah.
That's what it sounds like, kind of.
Yeah.
Not so much.
No, I'm thinking Indy should stick to her day job. Anyway, so now that we know Indy can't be a trumpet, we'll move on.
But
it's brilliant. Yeah. It's okay.
Carry on, Tracy.
So, thanks. All right, so they tell me a trumpet emits a sound of frequency 27.5 hertz. First piece of information. Calculate the wavelength of the sound if the speed of sound is 343 meters per second. Grade 10s, please be careful here. Sound is not the speed of sound is not a constant. It's not like the speed of light or electromagnetic radiation, which we give a constant of 3 times 10 to the 8. This value changes because it's dependent on temperature and it's dependent on the medium. Okay, so I'm sure some of you are looking at this and going, no, it's not 343, it's 330, or it's 340. It all depends. So in your tests and exams, you really should be given the speed of sound unless it's something you are required to work out. So it might be a value you're required to work out, but then you'll be given frequency and wavelength and all of that sort of stuff. So we want the wavelength. So they told us that my frequency is 27.5 hertz. They told me the wavelength is what I want, and my velocity or my speed is 343 meters per second. So we go, hang on, wait, we know this. We've done this equation today already. Of course you have, because V equals F lambda, okay, and V is 343, and we go, well, that's 27 and a half, and this is, we want lambda, so we divide both sides by 27 and a half, and I have this answer. It's 12.47 meters. Now, grade 10s, when I was looking at this problem, I had to say to myself, well, now, 27.5 hertz is very, very, very low. Not soft, low. It's a very low bass tone, okay? And a lot of people would probably struggle to hear it. Hearing is between 20, we can hear sounds between 20 hertz and 20,000 hertz, okay? So at 27.5 hertz, it's that bass sound that you hear. So I'm not 100% sure a trumpet can make that low sound, but we're going to put it out there. But it is audible, okay? Then, next part of it. Now it says, it's the same question. Calculate the frequency of the sound emitted by the trumpet if the wave has a wavelength of 0.33 meters. Why is it important that I've said to you that it's the same question? Because I haven't told you what the speed of sound is in this question, which means I have to assume it's the same as the question before. So for this next question, I want frequency. So I have to assume that it's going at, maybe I should write so you can read it, at 343, where my wavelength is 0.33 meters. Straight substitution. Okay, so V is 343, F is what we're looking for. Okay, we're going to divide by 0.33 on both sides, and if you were listening to this trumpet, this is a significant increase in the pitch of the sound, okay? This is a much higher pitch sound because it's got a higher frequency, right? Remember, pitch has to do with frequency, not loudness. Amplitude of the wave is how loud it is. Pitch is the frequency, okay? And that's sometimes we get confused between the two. Now, you got to remember that because I'm not sure if it's going to be in your grade 11 or grade 12 in the future, but you're going to do something called Doppler, and you've heard it like when ambulances drive past you or police cars drive past you on the road, and the sound changes. Okay, the pitch of the sound you hear changes because the frequency apparently changes. Okay, now, I'm wondering, Indy.
Yes.
Do you think we should go
Not
to
much.
Well, we try. Should we go to
try.
a quick break before I go into the next
Yes, I
problem,
like the idea of that.
Yeah.
Yes, I like the idea of that. Okay, guys, I see there's a whole bunch of you on the page. It's so awesome. How's it to Kaketso, to Ashworth, to Andile? There's even Vaynant. Vaynant says he's writing this tomorrow, which is pretty cool because I know a whole bunch of you have already written, but there's still a whole bunch of you that still have to write, so that's very, very cool. Jürgen Govender is on fire as well. He is, yeah, putting those answers on the page. It's so fantastic. Okay, guys, I think what we're going to do is we're going to take a break. Don't forget to learn more, learn extra, tune in, chat us on facebook.com/learn extra, and we'll see you now after the break. Hi guys, and welcome to Learn Extra Live. This is grade 10 physical science, and it's Indy and Tracy with you today, just in case you've just joined in. And if you have just joined in, I just want to remind you that big thank you to Liberty for making the show possible. You guys are awesome. We love you lots and lots. Guys, keep those questions coming. I see that there's quite a few interesting ones. We will be going over them in the last 15 minutes of the show. If it's really important, I might even jump in there with Tracy and ask her a few questions. But let's make sure that there's smart questions. But on the same point, there's no such thing as a silly question. Let's get them all answered now before your exam, so you don't have to make those silly mistakes. And Tracy is full of amazing knowledge, guys. She'll be giving you exam tips, telling you, if she says to you guys, this is important, then she knows. She's full of knowledge. So I think let's move over to Tracy and let's hear those wise words. Tracy,
Indy,
take it
amazing.
away.
It's
true though.
You can come back. It's
true.
fine. Thank you.
No lies.
Anyway, all right. Now, the next question. Guys, this is a new section to your grade 12 syllabus. It used to be in the grade 10 syllabus. It used to be in the grade 12 syllabus. They've dropped it down to grade 12. You guys can manage this. So I needed to put this in. Now, they tell you that a photon of electromagnetic radiation, so we're using a photon, has a frequency of 600 megahertz. Now, just remember, a photon is because light is quantized. Any part of the electromagnetic spectrum is. And this is where we get that little duality, which is quite a difficult concept to grasp, that light or any part of the electromagnetic spectrum can be both a particle and a wave, because it behaves as both depending on the situation. And when we consider it to be a particle, we call it a photon, and that has a certain amount of energy. So it comes in packets, okay, because it's quantized like electrons' charge is. So straight away they tell me we've got a photon of light with a frequency of 600 megahertz. Your conversions here are very important, grade 10s. We can't work with megahertz ever, because megahertz just doesn't make sense. We've got to work with hertz. So we've got to remember that mega means that I've got to times by 10 to the 6. Kilo would be times 10 to the 3. Mega is 10 to the 6. And giga, heaven forbid, 10 to the 9. Okay, so let's just put it here. So kilo would mean 10 to the 3. Mega means 10 to the 6. And giga means 10 to the 9. It's really, really big. It's very, very important, okay? Now, they ask you to calculate the energy of the photon. They want E. The only piece of information they've given you is the frequency, which I'm going to convert straight away. So now you've got to say to yourselves, okay, what do I need to use here? So you go to your information sheet and you realize that you have a very nice equation that we can use, which uses Planck's constant, which is energy of a photon is H times F. Planck's constant will be given to you. You don't need to learn it. It's named after a German scientist by the name of Max Planck. Okay, so it's not given to you, and it is extremely tiny. So what we get here is the Planck's constant is 6,63 times 10 to the minus 34. Okay, and we've got 600 times 10 to the 6, and this is where I really hope you guys know how to use your calculators, because the scientific notation really gets to you. I'm not going to do it, but I want to show you that on your calculators, and I'm hoping most of you have actually got the natural display calculators, is you need to use the times 10 to the X button. Okay, so I'm just going to show you over here. Hopefully they can, yeah, that one that I keep pressing, okay? Because what that does is it actually puts your number in. So when I put 6,63, okay, so I put 6,63, I press that button, then I don't need to do times 10, and I have a lot of kids who try to use the 10 to the X button. I don't know what you're doing. So there, that 6.63 is exactly what I've written down. Okay, so please be careful when you use your calculators. It's a silly place to make a mistake. So what we get when we multiply all of this out is we get 3.98 times 10 to the minus 25 joules. And it's tiny. This isn't a lot of energy. It never will be, okay, because it's actually, well, it's a high frequency wave, but it's going to have quite a small wavelength. But it's not a lot of energy at all. So we're not too worried about it, okay? Now they say to us, calculate the wavelength of this radiation. There's two ways you can do this. You can go the route of saying, well, E equals hc over lambda. But my problem with doing it this way, and this is just me, is this relies on my first answer being correct. So what if this answer isn't right? Then this answer isn't going to be right. Then we've got a double error. Now, that error should be carried down, but sometimes it's not, because that's not the only way to solve this. We're looking at electromagnetic radiation, which means I can use this equation. And I'm hoping you're all telling me, well, we know what C is, because C is the speed of light. All electromagnetic radiation doesn't matter. And C has a constant value, which is 3 times 10 to the 8. We know the frequency, it's 600. And we want lambda. Now, when we divide 3 times 10 to the 6 by 600 times 10 to the 6, lambda works out to be 0.5 meters. It's tiny. It's a relatively small wave, so we're quite happy with that. But now comes the fun part. What type of radiation is this? Now, grade 10s, you do not need to know the exact values of the spectrum, okay, of all the wavelengths. You don't. But you should have a good idea of the range of wavelengths. Okay, so I'm hoping some of you right now are going, well, this is actually a relatively big wave compared to what we get with gamma rays. They are tiny, they are minuscule little waves because they have extremely high frequencies. 600 megahertz is still quite high, but it's not as high as we have for gamma rays and that sort of thing. So what this actually is this is a microwave. Okay, microwaves can be as small as 1 centimeter and as big as 1 meter. So this is 0.5 meter, so it fits into the microwave range. And hopefully your teachers will be a little lenient on that, but that is the sort of detail you do need to know. Why? Because you do. Now, also make sure, grade 10s, that you can give the electromagnetic spectrum in order, either in order of frequency or wavelength, but you must read the question properly, because we can ask you to do it in decreasing order of wavelength, increasing order of wavelength, however, depends on how nasty we are feeling at the time when we set your tests. Now, state one use of this type of radiation. I think this one's probably the most obvious. What do you think? What would a microwave be used for, Indy?
For heating food?
There we go, for cooking. For cooking. In our microwaves. There we go. See, even Indy
I thought
can
that
do
was
it.
a trick question.
Not at all. I think it's the nicest one out of all of them.
I never know.
No. Well, also radio waves. What would radio waves be used for? Radio broadcasts. Nice and simple. That's why they call those gaps.
Easy.
So, putting it out there, just making sure you learn something.
I'm listening and I'm
Brilliant.
learning. Yeah.
That's impressive. Multitasking.
Impressive.
But you're a girl. It's okay.
Of course, we do
All
that
right.
easy.
So, let's go into some more with magnetism. Okay, now this one, I just wanted to show you a different type of question where we can actually ask you a lot of stuff to do with your theory. Okay, you should be getting multiple choice and one word answer questions. They are very, very, very important. Okay, so here we go. And we're going to look at this and says, give one word or term for each of the following. So the first one is a description of the position of geographic North Pole, of the geographic North Pole of the Earth. Okay, and what that is we call that true north. Okay, that's actually called true north. Then, a compass needle is this type sorry, I'll just throw my pen around.
Throwing her things around.
Just throw my toys. A compass is this type of this type of magnet. I can actually read, and I'm hoping because we only have two types of magnet. They're either permanent or non-permanent, and you're going, oh, wait, it has to be permanent. Okay, so it's a permanent magnet. Brilliant. The direction in which a freely suspended compass needle, ignore that S, points to. And we've all got to go, hang on, wait. Which direction do all compasses point? North. Which is really important. If it doesn't point north anymore, then it's broken. All right. Then, the property of unlike magnetic poles that causes the north pole of a compass to point towards the south pole of a magnet. That's because unlike poles attract. Okay? The angular difference between magnetic north and true north. Now this is a fun one because this is the angle of declination. So it's one of those funny words. Okay, now grade 10s, and I get asked this all the time, does spelling count? To a certain extent it does, and what I tell my learners is if it's phonetically correct, so if I read it and go, okay, you're on the right track, then that's fine. But sometimes I get all sorts of things and I'm like, yeah, I'm not really sure, then spelling is definitely a problem. Okay, obviously you want to try learn to spell it correctly. Okay, so one more question before we go to another break.
Yes,
because we can handle this.
Yeah, that's good. We can.
So what we have here is we have quite a detailed little description. I'm going to take that away because it's irritating. Okay, it says two identical, so they're the same. Brilliant. We need to remember that. Okay, let's do it green. Two identical insulated spheres are suspended from threads and held a small distance apart. Okay, so what that means, and I'm going to draw a little diagram, is over here we have two identical metal spheres, okay? The charges on the spheres are minus 3 microcoulombs and plus 2 microcoulombs. When they are released, they move towards each other. Are you all telling me why? I'm hoping you all, well, that's the first question. Explain why the spheres move towards each other when released. Because you're all screaming at the TV right now or furiously typing on Facebook because they're unlike charges and opposite charges attract. Nice and simple. Explain why opposite charges attract. Nice and simple. Nothing difficult. This would be only worth 1 mark in an exam. You don't have to go into a long, convoluted explanation. Please be careful, grade 10s. I see this all the time, particularly if you know your work really well and you've learned a lot of stuff. You tend to want to write too much, and then you don't finish your tests and exams, and you wonder why. It's because you're writing too much. Be careful. Then, the two spheres now touch each other. That means conservation of charge becomes an issue. Okay? And now they ask you to calculate the new charge on each sphere. All right. First of all, my first charge was minus 3 microcoulombs. We must convert this to coulombs. So that means this is minus 3 times 10 to the minus 6 coulombs. You must learn these conversions as well. So now we go on the opposite end. So with frequency just now, we had very, very big frequencies. Now we've got very, very tiny charges. You won't use big charges, okay? They're going to be tiny. Because when we're talking about insulated spheres, you're talking about tiny little spheres, okay? The size of tiny marbles or little beads and that sort of thing. So they're tiny, tiny, tiny. So that's Q1. Q2 was plus 2 microcoulombs, so that's plus 2 times 10 to the minus 6 coulombs. And now we remember that what the conservation of charge says to us is that charge, it cannot be created or destroyed. It's simply going to be transferred, which means that when these two spheres come together, okay, they're going to come together and the charge will align itself evenly around the spheres, and then when we separate them, they're going to have the same charge. So that gives us this equation, which probably won't be on your information sheet, by the way, especially not in that format. So there we go. We're going to divide by 2. So we're spreading the charge out. So we have minus 3 times 10 to the minus 6 plus 2 times 10 to the minus 6, all divided by 2. Now we put this on our calculators. I've got minus 3 plus 2 gives me minus 1, okay, which we're then going to divide by 2. And let me show you on the calculator so you can see where I get this from. Okay, so I'm going to go minus 3 to the minus 6 plus 2 times 10 to the minus 6. Okay, I'm now going to divide by 2, put it into normal notation, and it's minus 5 times 10 to the minus 7. Okay? It's a negative answer because the negative charge was bigger. Okay? And it's now gone to a smaller decimal because it actually ends up being 1 divided by 2, which is a half. Okay. Then, last question before we take a quick break. Now it says, what type of force is there between the spheres now? Okay, what type of force is there? Oh, and the green has just decided to go on holiday. And then they say, explain. Well, what's happened? They're both now negative. So the force is now repulsion. Why? Because they both have the same charge. Okay, so your answer is what type of force? Repulsion. The explanation, both spheres now have the same charge and like charges repel. Okay, I think it's a good place to take a break.
I think so too. Okay, Mindsetters, I hope you're all following. I know that a whole bunch of you are actually really enjoying it. Now that it's colder, you're all sitting on the couch, the hot cup of chocolate or tea, and they're saying, Trace, they can't believe that they're sitting in front of the couch on, doing nothing, but they're actually learning while they're doing it, which is fantastic. Good. Learning more and learning extra, and that's why we are here, Mindsetters. Before we take a quick break, don't forget we are giving away a Casio calculator to the best post on Facebook, and right on that note, please post your questions because I think when we get back we're going to have about 5 minutes left or so. Okay, see you now after the break. Hi guys, and welcome back to Learn Extra Live. I think we are entering our last 10 minutes of the grade 10 physics show. So if you have just tuned in, you're a little bit late, but it's okay, join in. Esmeralda and Coquetso, you say you're a little bit confused about the photon, but guys, please let me know, where are you confused? If there's something that you're confused with or not understanding, try and explain as much as you can on the page, and it'll make it much easier for us to get through all of the questions and get everything answered in time. I think in the last, let's say 5 minutes of the show, we're going to go through all of your questions. Quick. Trace, should we take it away?
Okay, so we're back. Now, quickly what we're going to do is, because I think it's quite important that we look at these, is we're going to do a quick circuit calculation, okay? Because we didn't really get to do a lot of these last week. Now, remember what I said to you guys last week is use your highlighters, all right? I told my grade 10s that today. They looked at me like I live on another planet altogether, but that's okay. They'll get over it. Okay, so out comes the current, or it goes through the ammeter, gets to this point over here. It's going to split, but we need to remember that it'll all join back up, go through R over there. So what I'm saying is the middle part is now going to be a parallel section. It is 2 different values, so some will go through the 3 amps, and I'm going to take these off in a second because you need to see the values, and some will go through the 6 ohms, okay? Now, why do we do this, grade 10s? Because we need, what you guys really struggle with here is recognizing things like these 2 sections are in parallel, which means that voltmeter reading is the same as the voltmeter over that resistor. Okay? Oops, and now it's just gone flying around. This voltmeter reading plus this voltmeter reading must give me the total because they're actually in series with each other. The ammeter reading over here is actually in the series circuit, so that ammeter reading is the reading for all the current. Important information. Now, I need to take all my scribblings away so we can see the values to do the rest of the question. So we're just going to take these out, okay? Just so we can see. Now, the first thing they ask us for is the reading on V3, okay? So we look at this and we go, okay, V3, and I look and we go, well, for V3, I know resistance, and I know the current. They told me that it was 2 amps. Brilliant. We're going to use Ohm's law, so I'm going to use 3 ohm. Remember I said to you, we put the little subscripts because we need to name the resistor. It's like Indy and myself, we don't just like being called girl. We like to have a name. I'm a girl called Tracy. Indy's a girl called Indy. Because if we just called each other girl, it would just get annoying.
Hey you.
Yeah, hey you's
Hey
even
you.
worse. There we go. So now we're using V3, and I'm going to use the current through that 3 ohm resistor. Okay, so we go, alrighty, what do we know? Well, I know that I've got 3 ohms. I want V3, and my current is 2 amps. So V3 equals 6 volts. Okay, now what do we do? Because the biggest issue here is that we get confused. So we go, okay, back to our question. That's 6 volts. I'll write it in. Brilliant. All right, next question. Calculate the reading on the ammeter, A. Okay, so now we go, okay, I need the reading on the ammeter. So now we're going to say to ourselves, ideally, because it takes all the current, we would want to go all my voltage, all my resistance, and work it out that way. But there's 2 problems with this. Number 1, I don't know my total voltage. And number 2, I don't know my total resistance because I don't have R. But I know this is 2 amps. I know that is 6 volts. I can work out the current in the 6 ohm resistor. Okay, so I can work that out by doing this. Watch. So the current in the 6 ohm resistor, so I'm going to do it here, is going to be V3 and the current there. So it's 6. I know that's 6. So, and I'm going quite quickly because I want to get to your questions. So it's 6 amps, and now we remember that my total current is going to be the current in the 3 ohm branch plus the current in the 6 ohm branch. So it's going to be 2 plus 1, which is 3 amps. Oh, nice and easy. Then we go back to our question and we write it in. Okay? Now the next question actually asks us to work out R over here. But we go R's in series, so R has 3 amps going through it. Yay! Easy. R is going to be the voltage over R divided by the total current. So it's going to be 6 divided by 3, 2 ohms. Yay! Okay, and I'm going really quickly so I want to get to our questions. And then the very last question of this particular one wants to know what V total is. Okay, now I'm going to do it in another color so that you can see it. But my total is my 6 volt one plus V3 because they're in series with each other, which means it's 6 plus 6. It's 12 volts. Now, grade 10s, when it comes to circuits, there's always more than one way to do this, okay? Depending on the way the question's asked, there's always more than one way. So I'm pretty sure some of you at home are going, can't I do it this way? Of course you can. You could have worked out your total resistance and then worked it out if you wanted to, but I'd prefer not to because it means working with fractions and stuff. Don't really want to do that. Up to you. Okay, so, Indy.
Okay.
Let's see what we've got.
Let's see how many we can get through,
Yes,
Tracy.
let's do this.
You could obviously see me waving. Hey,
Okay,
come on,
let's do
questions.
this. Okay.
Okay, so let's go. Question number 1 from Lucinda. why can't we just work with microcoulombs? Microcoulombs.
Lucinda, because microcoulombs is not the SI unit. Okay, and you need to get into a good habit of changing it to the SI unit, which is coulombs. Microcoulombs are very tiny. Okay, it's not going to make too much of a difference with your grade 10 calculations, but get to grade 11 and grade 12, where it is of huge importance. That is a real problem for us, okay? So you've got to get used to using your SI units. Just like when we look at distance, we don't use kilometers, we use meters. All right, we've got to use the SI unit, okay?
Okay, let's have a look here. Okay, so this one is from Larissa, and she says, okay, it's quite a lot. There's a few questions in it. Do we have to substitute in, or can we do the triangle method, where you just rearrange the equation before attempting it, or will you be marked down for not substituting?
Okay, I know exactly what she wants. All right, Larissa, this is a thing about whether you want to get your marks or not. Okay, because remember, for example, this is R equals V over I. That's the equation. Now, I know a lot of you want to use the triangle, and I know some of you do know how to use the magic triangle. I just prefer not to do it because I have a principal issue. It's not that, I just think it doesn't teach you much about maths. Okay, so it's just my issue, and it's a banned word in my class. But what you need to remember is this is the equation on your information sheet. This is the one we want. If you rearrange this equation and you start and you're looking for voltage and you go V equals I times R, not a problem. If you substitute in after that, you'll get your full marks. But what if you tell me, and this happens, I see it all the time, that V equals R divided by I? That's completely wrong. We don't even look at your substitution after that. Okay, that's my problem here. And that's because that equation is not even vaguely right. That's correct, and that's correct. You could also write I equals V over R to start off with, not a problem. I also know that what a lot of you do is you write down the equation, so you know that you've got to use R equals V over I, and then you'll go V equals I times R, and then substitute in. That's also fine. But if you go R equals V over I, and then say for some reason you get confused with the maths, and you now go V equals R over I, we stop marking. So you only get a mark for the equation, which is why, in order to make sure you get your marks, it really is better to rather go R equals V over I, substitute in the values you know, and then manipulate. So say I know R and I know I, like we did just now. You've got 2 out of your 3 marks. If from here you make a complete hash, it's okay, because it happens. But then we can give you marks for getting this. Okay, so it's a preference more than I have to, but it's to make sure you write the right equation and get it right from the start. And I hope that helps.
Yes, okay. So how much time do we have? Not much, indeed, at all. Let me see. How can the current be more than the resistance? Question mark.
That's a value thing, guys. You can't.
Oh, she meant. I'm sorry. She said. I meant. How can the resistance be more than the current?
Oh, absolutely. No, absolutely. The resistance often will be, the value of the resistance will be more than the current. Remember, resistance is just an indication of how hard it is for the current to get through, whereas current is an indication of how much charge gets through per second. So it's in fact 90% of the time you're going to have a much higher resistance value-wise than the value of the current, but they're not measured in the same unit. So they don't have to be the same, they don't have to be vaguely close to each other at all.
Okay, so now let's see if this one we can help Charmaine. Charmaine says, I don't understand number 1, Tracy, because you were dividing, but the answer became 6. How come?
Number 1 over here.
I think so.
That's because to take the 2 over, okay, I need to times both sides by 2 over 1. So the 2's cancel out, and then I get 2 times 3.
Okay.
So that's where it comes from. See, now this was what I was talking about in terms of the substitution just now. In that if this is an issue manipulating it, at least I would get 2 marks for that if I didn't get the right answer.
Yeah.
Yeah.
Fantastic. Okay, so guys, I think what we've done is we've run out of time. if there
Yeah.
is anything you still don't understand at the end of the show, you can actually just post them onto our page and we will get to them. We will get somebody to answer them for you.
And next week's chemistry.
Yes. And next week is chemistry, guys. Don't forget to learn more, learn extra. We'll see you same time, same place next week. Grade 10s, grade 11s, don't forget you next. Also, quick thing. Jürgen Govender says, I believe that the best way to learn physics is to love the subject. And grade 10s, my advice is you to get in the mindset of loving the subject, and then you'll see your mark improving like big time. I'm serious.
I like it.
And he says it worked for him. So grade 10s,
it.
have a fantastic day. See you later. Bye.